In this video, I'm going to start with number 15. A boat with a water speed of 60 feet per second is to be used in a river, which has a current of 20 feet per second going south. Okay? What is the resultant velocity if the boat is headed north? Okay? So the boat is heading north at 60 feet per second, but the river is going south, so you do head to tail again at 20 feet per second, and this is feet per second. Your resultant is right here. It's connecting the very first origin to the last arrowhead, and that should be 40 feet per second. That's an easy one, right? Or you can just do 60 minus 20. 60, since north is positive, south is negative, you just do 60 minus 20. Okay. What is the resultant velocity if the boat is headed east? So the boat is going east at 60 feet per second, but the river is going down, or south, I mean, 20 feet per second. So you have to do head to tail, and here is your resultant. And you have to figure out what that angle too is. So to find the resultant, you do Pythagorean theorem, and you should get an answer of 63.25. And to find this angle, I'll call it theta here, you're going to have to do the inverse tangent of 20 over 60. And you should get an angle of 18 degrees, and it's south of east. You can probably see that in there. All right, for number 16, I'm going to do it two ways. I'm going to do the vector resolution. I'm going to do law of cosines also. All right, so here we go. So for Chris, it falls south of east. So here is Chris. And this angle here is 20 degrees. Okay? So here's Chris. So I'll make the triangle. So here's the x component for x, and here's the y component for x. So for Chris. And this angle here is 20 degrees, and this is 34 newtons. Okay. And then we have Rob. He's going north of east. So Rob is this way. Yeah. Okay. So here's the x component. Here's the y component. So this is 28 newtons. And this angle here is 55. And that's it. Okay. So now if we look at, I'm going to put C for Chris and R for Rob. R for Rob here, because then this is the resultant. So for Chris, it's going to be positive and negative, because it's right and down. For Rob, they're both going to be positive. Now if you do a little bit of trig here, these are the numbers you're going to get. I'll add into it. So for Chris, it's going to be 34 cosine of 20. You can figure out what that number is. And 34 sine of 20. Okay. And for Rob, it's going to be 28 cosine of 55. Okay, it's this one. This is Rx. And this is R. This is Rob. Rob Y. Okay. And this is going to be 28 sine of 55. Now you put that stuff in your calculator, you add, you should get 48 here. And 11.31. Yeah. Now, basically, it's positive and positive, which means the x component is this way. So you always start with the x component. It's 48. The y component is 11. Oh, going up. It's 11.31. Here's your resultant. Okay, so you can do Pythagorean theorem. You can figure that out, and you can get this angle here, theta. So after you finish, you should get 49.31 newtons at 13.26 north of east. I'm going to try to do the same one, but this time using law of cosines. Okay. So we have, okay. So I'm going to go with, I don't know which one I'm going to go with. I'll go with, I'll start with Chris. So Chris is going south of east, and that's 20 degrees. And I'm going to try to do this to scale as much as I can. So this is 34. This angle here is 20. Then I come to the head here, and I do 28 degrees, 28 newtons, but at 55. So it's a sharper angle. So I'm just going to say that's 28 newtons, right? Okay. My resultant is right here. Okay? Law of cosines is quicker, much quicker. But only if I can figure out what this angle is here. Okay? Now, I think we can figure that out. See? This angle here is 20, which means this angle is 20. Okay? They are alternate interior, right? This angle here is 55. So now you get 20 plus that question mark plus 55. That should add up to 180. So that question mark should be it looks like it's 105 degrees. Now here's how the law of cosines works. R squared equals 34 squared plus 28 squared minus 2 times 34 times 28 cosine of the angle facing what you're looking for, 105. And then you can take the square root out, and you can take the radical of all that stuff. So let me try that. 34 squared plus 28 squared minus 2 times 34 times 28 cosine of 105. Take the square root of that, and we get 49.32 newtons. I think earlier I said 49.31, pretty close. Now the next thing we have to do is we have to figure out what this angle is. Okay? Now this is 105 here. Now I'm going to do law of sines. And I'm going to try to find this bigger angle. And once I find that, to find this small angle here, let's just call that theta, I can subtract 20. So I'm going to do law of sines for that. Now this is 49.32 newtons, right? So sine of 105 over 49.32 equals sine of this big angle here, I guess I call it phi, over 28. Now this angle here is 33.25, or it could be the supplement. So you have to be careful. Sometimes it could be the supplement. So 180, the supplementary angles have the same sign. Or it could be 146.75. Okay? Now I think the second one is not an option. Because if I make this 146 and this is 105, I'm already past 180. So that one is out. But sometimes that one works, but this one doesn't. So this is 33.25. You take 20 away, so you're left with 13.25. And I told you earlier the angle was 13.26. And it's north of east. All right, let's look at this tug of war problem. Now, if you have more than two forces, you cannot do law of cosines. Well, you can, but it's just complicated. Okay. So I'm going to write the x and the y, and I'm going to write the components. So this is Jane, this is Joe, and this is Tom, and this is the resultant. Okay. So Jane is going north of east. So Jane is like this. This is the x, this is the y. Okay. Now, it's positive and positive. Joe, north of west. So this is Joe. X and y. Okay, so negative and positive. Tom just goes straight south. So this is Tom. So basically, there's nothing in the x component, and it's negative in the y direction. So this is basically just 32, but negative. Okay? Now for Jane, this angle here is 45 degrees, and this is 35. For Joe, this is 30, and this is 45. So if we do the math here, this is going to be 35 cosine of 45. This is going to be 35 sine of 45. This is going to be 30 cosine of 45. See how I did put the plus and minuses first? This one I don't forget. 30 sine of 45. If we add, oh, I got this in the wrong place. This is 0 and negative 32. If I add, this is what I get. I get 3.54 positive, and I get 13.96 positive. So all I have to do now is just make the triangle. So it's positive 3.54. Go down this way, and that's 13.96, and that's the positive. What am I doing here? This is 13.96. Okay, and we have to figure out what this R is. So if we do Pythagorean theorem, we can also figure out what that angle is. So if you do Pythagorean theorem and you do the inverse tangent of 1396 over 3.54, you get an angle of 75.77, that's 76 degrees, and R is 14.40 newtons. Okay. All right. The next question says, what force should Lindsey exert so there is no winner, right? Now, the winner here is basically going to be the one that's going to be closest to the resultant. So you just go back and figure out which one is closest to the resultant. Now, Lindsey has to actually apply a force equal to the resultant. So this is Lindsey, right? Okay, and at that angle. So she should apply 1440 newtons at 76 south of west. Okay, so in order to have a tie. There's a plane going west, but because of wind, it ends up going northwest. Okay, so there is a 25-degree north of west. That's the direction that the plane is going. And for this problem here, we're trying to find the speed of the wind and the direction of the wind. All right, so we're going to try to do this two ways. We're going to do it with the law of cosines, which I think is quick. So to do law of cosines, we're going to do 285 squared, W squared, equals 285 squared plus 400 squared minus 2 times 285 times 400, cosine between the 285 and 400. And then, after you're all done, you should get a W equals to about 186, 185, 198 to be exact, miles per hour. Now, to find the angle, I'm going to try to go after this angle, and once I'm done, I'll figure out this angle here with respect to the west. So to find out what this angle here, let's call it theta here, so it's sine theta over 400 equals sine of 25 over the 185, 198. And if we do the math, we get theta equals 65 degrees, about 65 degrees. Okay? Now, it could be 65, or it could be the supplement of 65, which is 115. That's when you have to go back to the triangle and see which one of those two makes sense. Yeah, I don't think the 65 makes sense because, let me just record this. This is 185, 198. Okay? So if I put a 65 here, okay? And this angle here would be, what is that? 90. Okay? Now it looks like I have 400 across from 65 and 285 across from 90. That doesn't make sense. Because across from the 90, I should have a bigger angle, a bigger number than 400. So this has to be 115. Okay? Which leaves us with 65 here. Okay? Because that's 180. So the answer should be 185.98 at 65 degrees north of west. Okay, so that's one way of doing it. Now let's look at the other way, which is basically making a chart. So in this case here, this is a little different than before. In this case, we do have the resultant, right? And we have to find components for the wind. And we have, this is 285, and we have information about the 400. So the plane is going to the left, so this is a negative. This is 0, there's no y component. We have to find, I guess I call this Wx and Wy. And for the 400, it's negative and positive. So negative here and positive here. Right? Now you can take this 400, right, and make it a triangle and figure out the components here. So, so this is going to be 400 cosine of 25. And oh, not there. 400 cosine of 25 here, and 400 sine 25 here, and this is just going to be negative 285. Okay. Now basically, negative 285 plus Wx should be equal to negative 400 cosine of 25. And the other equation should be these two added together, 0 plus Wy equals 400 sine of 25. And I think once you find the components, you get Wx is equal to negative 7752 miles per hour, and the Wy equals 169.05. Okay, and you make your triangle. So this looks like it's left. We start with the x components first, and you would do head to tail. So you go left, and you go down. No, you go up. Left and up. Okay, so this is 7752, and this is 169.05. And you just have to find out what this W is. So you can do Pythagorean theorem, you can figure that out, and you have to find this angle by maybe doing the inverse tangent of 169.05 divided by 7752. And you should end up with the same answer. Okay? So, and you only do this law of cosines if you have, if you're only dealing with triangle. Okay? And you have to pay attention, be careful with this. When you find the angle, you have to go back to the triangle and make sure that it does make some sense. Okay. All right, let's see which one of these people is right. We'd have to know the direction of the vectors to know how big the resultant is going to be. Okay? Where it says, since we are only asked about the magnitude, we don't have to worry about the direction. Well, in vectors, direction is extremely important, so that's wrong. Okay? This person is wrong. We have to know the direction of the vectors to know how big the resultant is going to be. Alexis is correct. Direction, you have to know the direction and the magnitude. And you already have the magnitude of both. Okay? And Kara says that you can just use the Pythagorean theorem. Well, we don't know if they form a 90-degree angle, so we can't go by that. Okay, the resultant is the vector that you have to add to the first vector to get the second vector. That's not true. Okay, this is not one-dimensional. It could be in any direction. So the bottom line is that the answer for this problem here, I'm just going to sidetrack here, is anywhere. The magnitude is anywhere between 2 and 8. Somewhere between the difference of this 5 and 3 and the sum of 5 and 3. All right, let's look at this last one here. Okay. So the magnitude is less in case A. And here's the reason. The x component in both cases is going to be 0. The x component of the resultant. Because if you take this and you project it here, and you take this and you project it here, you're going to be equal and opposite. And you're going to end up with the same thing on the other side. Now, if you take this 3 and this 3 have the same angle as the 6 and the 6. Okay? But this 3 and this 3, even though their x components cancel, but they're going to have a bigger y component than if you place them here. Just think about like taking this 6 and breaking it into 2 pieces, a 3 here and a 3 here. And do the same thing here, a 3 here and a 3 here. Okay? So this 3 and this 3 are kind of like here. So this will give you the same y component of the resultant. But these 2 here will give you something more vertical because they are closer to the vertical than these 2. These 2 are not vertical, or are not as vertical as these 2 here. Okay, so that's if you want to do it with conceptually. Now let's see how we can do this with the math. Now for this guy here, the y component would be 6 sine 45. Okay, so you're looking for this. We already said that the x components cancel out. But you have these twice, so 2 times that. Okay? Now let's look at it here. You have 3 sine of 45, and you have that twice, plus, that's from these 3's here, and you have to do the y component for these 3's, right? Basically doing this component here, that's the y. And that's 3 sine of 75 times 2. Okay, and if you do the math here, I think we don't have to compare the 2's here. If you do the math, you're going to find that this number here is less than that number. Okay, so you can do it either way. All right, thank you.